Hello. In this video, we are going to discuss circles as conic sections. So first, what is a conic section? A conic section is when a plane intersects a double cone. A double cone. Let's look at some pictures to get some visualization of this. Here we see three double cones, each being intersected by at least one plane in different angles. Okay? Each of these create four different types of conic sections. Those four types of conic sections are circles, ellipses, parabolas, and hyperbolas. In this lesson, we are discussing circles. I just circled the cone that is being intersected by a plane that creates a circle, okay? Here, we can see that this plane is parallel with the base, which is what makes it a circle. So on the previous slide, we saw that the plane was parallel to the base of the cone, okay? Anytime that happens, it's a circle. The circles have a center, a diameter, and a radius. And the equation is in standard form, okay? This is standard form of the equation. X minus h squared plus y minus k squared equals r squared. So our center is hk. Notice that the formula, the standard form, has a minus. So if you have x minus 2, the center is 2, okay? You have to change the sign from the formula to the center. Then the radius is the r. Whatever number the standard form equals, square root that number, you will get the radius. So let's look at an example. In this problem, we're going to graph the conic, okay? So we have x minus 1 squared plus y plus 5 squared equals 4. Okay, so we know this is a circle. As we dive in farther and farther into conic sections, we will learn how to differentiate between these or distinguish between the different forms. But we know that this is a circle because we have x is squared, y is squared, and they are both positive ones, okay? Positive 1, positive 1, positive 1, positive 1. So let's look at this. We know that it's minus h minus k. Here I see a minus 1 and a plus 5. So my center, I have to change that minus 1 to a positive 1. And I have to change that positive 5 to a negative 5. That's my center. Now my radius is going to be the square root of the number that I equal, which in this case is 4, and the square root of 4 is 2. Therefore, the radius equals 2. So let's graph this. The first thing we need to plot is the center. So we're going to go out 1, down 1, 2, 3, 4, 5. There's our center. Now our radius is 2, so I'm going to use my radius to go in 4 directions. I'm going to go up 2, to the right 2, down 2, and to the left 2. And I'm going to sketch this the best that I can to make this a circle. Oh, that curve was actually pretty good. Oh my gosh. Okay, but y'all get the picture. My circle drawing is not great, especially when I'm drawing on a computer, but we can get the picture that this is a circle. So that was graphing a circle as a conic section. So now we're going to start looking at different equations and determining if they are circles or not. So on this slide, we have 4 different equations, and we have to determine do they meet all the stipulations in this form. So the first thing that I'm looking for, do we have 2 squareds? Yes. Are my x and y, do they have the same sign? Yes, they're both positive. Do they have the same coefficient? Yes. So this is indeed a circle. Okay, let's go ahead and identify the center. I'm going to write it in black. So the center, I have to change the 2 from a -2 to a +2, and I have to change the -3 to a +3. And then my radius is the square root of the number which we equal. So the square root of 25 is 5. Okay? Let's move to the second equation. The first thing I need to check is to make sure that both are squared. And they are. The next thing I need to check, are my x and my y, are they the same sign and do they have the same coefficient? Yes, they're both a positive 1. So we know that yes, this is a circle. Now we need to identify our center. So I need to change the sign of my positive 12 to a negative 12. And I need to change the sign of my negative 3 to a positive 3. And then for my radius, I need to square root this number here, which is the square root of 12, which equals, remember, the square root of 12 breaks down to 4 and 3. The square root of 4 is 2, and the square root of 3 is just square root of 3. So that's going to equal 2 square root of 3. Let's look at the next one. I have 2 squareds. Let's look at our y's and our x's. This is not a circle because I have this negative right here. So this is a no because of the negative. Let's look at our fourth equation. Both are square. Oh, both are not squared. So this one is a no because the y is not squared. Because the y is not squared, this is a no. We're going to do some more, don't we? Here, we're going to have, 3 equations. I can't remember how many were on the slide. So we're checking to see. Okay, you're saying, all right, these are not in standard form. And that's fine because we can still check the same things. Are my x and my y squared? Oh, I want to write these in yellow because red means that it's wrong. All right, are my x and my y squared? X squared, y squared, yes. Are my x and my y, are they the same sign and do they have the same coefficient? Positive 2, positive 2. Yes, this is indeed a circle, okay? In this form, we cannot identify the center or the radius, but we will learn later on how to do that. We will use a process that we've learned in the past, completing the square. So let's look at our second equation. 2x squared plus y squared plus 5x plus 3y equals 22. Here, my x is squared and my y is squared. Now let's look at the coefficients for x and y. Here I have a 2x, and for my y, I have a 1y. So no, this is not a circle because the coefficients do not match. Let's look at the third equation. X squared minus y squared plus 3x plus 4y equals 34. First question, are my x and y both squared? Yes, they are. I see an x squared and a y squared. Second question, do my x and y match? Do they have the same coefficient? I have a 1x and a negative 1x. They're the same coefficient, but they have opposite signs. Therefore, this is a no. That was a terrible N. This is a no because they have opposite signs. Because x is positive and y is negative. Okay, on this one, we're going to graph the conic. Now, we need to get this equation into standard form. We're going to do that using completing the square, okay, is what we've learned in the past, all right? If you need a refresher, go watch the video about completing the square. So I'm still going to break it down, but an in-depth lesson of completing the square is not going to be present in this video. Remember, we have to set it equal to our constant. So the first thing I'm going to do is I'm going to move this 7 to the other side. So I have x squared plus y squared minus 8y equals negative 7. Now, in your mind, you need to group your x's together and your y's together. What I do notice is that I don't have an x, so I don't have to complete the square with the x term. So I'm only going to complete the square with the y terms. So to do this, I'm going to half 8, which is 4. Then I'm going to square 4, which is 16. And then I'm going to add 16 to both sides. Okay? Remember, completing the square, our saying for completing the square was half it, square it, add it to both sides. So we're going to leave our x squared alone. And then we have y squared minus 8y plus 16 equals, and then negative 7 plus 16 should be 9. Yes. I'm going to double check before I had a mathematical error on a video. Okay. Now our goal here is that we now have a perfect square where we can factor y squared minus 8y plus 16. Remember, I'm looking for two numbers that multiply to give me 16, but add to give me a negative 8. And those two numbers are negative 4 and negative 4. So now I have x squared plus y minus 4 squared equals 9. Because if I factor this to the side, y squared minus 8y plus 16, 16 has the factors of 1 and 16, 2 and 8, or 4 and 4. Negative 4 minus 4 equals negative 16. So now I have y minus 4, y minus 4. And because it's the copy, I see the same y minus 4 as two copies of each other. So I can do that as y minus 4 squared, which then goes right there. Okay? So I don't have anything with my x, so I can imagine that this is x minus 0 squared plus y minus 4 squared equals 9. So let's identify our center. Our center is 0, and then remember we have to change the sign of the 4. It's a positive 4. And then for my radius, I have to square root that 9, so that's a 3. So to graph this, I'm going to go 0, 4, 1, 2, 3, 4. And then I'm going to go 3 in all 4 directions, up 1, 2, 3, to the right 3, down 1, 2, 3, and to the left 3. And then I'm going to try to draw this circle the best I can. As we saw on the previous slide, I'm not that great at it, but try my best. That's what matters. Oh, that one was better than the first one. Okay, I'm pretty impressed. All right, so that is graphing conic sections. Remember, if you're not familiar with completing the square, go back and watch that video. And in our next video, we're going to proceed to moving on to parabolas. I'll see you then.